Welcome, my dear students. We are going to study preparation and structure of silicon tetrachloride. Silicon tetrachloride was first obtained by John Jacob Berzelius in 1823 and is formed by the union of its element when dry chloride is passed over heated amorphous or crystalline silicon. In the laboratory, SiCl4 can be prepared by treating silicon with the chlorine. Si plus twice Cl2, it gives a SiCl4. Silicon tetrachloride is prepared by the chlorination of various silicon compounds such as ferrosilicon, silicon carbide, or mixtures of silicon dioxide and carbon. Silicon tetrachloride obtained by passing chlorine over a ferrosilicon containing 15% of silicon, means alloy of iron and silicon containing 15% silicon, which is heated to redness in a fire clay retort. Similarly, also it is formed from the cuprosilicon. It is obtained from the cuprosilicon. Second, that is a silicon carbide in a solid state, and in a presence of Cl2, it gives the silicon tetrachloride in liquid state and carbon tetrachloride in a liquid state. Third one, that is a SiO2, silicon dioxide, plus twice Cl2 plus twice C. This carbon, it is in a solid state, silicon dioxide, it is in a solid state, chlorine in a gas. It gives a silicon tetrachloride by T plus twice CO, carbon monoxide. Silicon tetrachloride is a colorless liquid that fumes in all having density of 1.483 gram per centimeter cube. It is a volatile liquid, boiling point 330.57 Kelvin. It is soluble in a benzene, toluene, chloroform, ether and hydrochloric acid. It has a tetrahedral structure with a coordination number 4. It is used to produce high purity silicon and silica for commercial application. Silicon halides are mild Lewis acids. Silicon can form complexes due to availability of d orbitals. Silicon halides are rapidly halogenized to water to give silicon acid. The silicon tetrachloride is a covalent compound. Silicon is a metalloid. The structure of silicon tetrachloride, if you consider, then silicon, it has atomic number is 14. Electron configuration of 14 silicon is equal to 1s2, 2s2, 2p6, 3s2, 3p2. Valence electron configuration is 3s2, 3p2. Electronic structure of silicon in ground state, 3s which contains 2 electrons, 3p which contains the 2 electrons, that is px, py, pz orbitals which contains the 2 electrons. The one is a orbital empty, px and py which contains 1 electron each. Electronic structure of silicon in ground state, the s orbital containing electron, it is promoted to the p orbital. Then 3s which contains 1 electron, 3p which contains the 3 electrons. Means 3s electron which has 1 electron and 3p electrons, that is the orbitals px, py, pz which contains the 3 electron. Then the hybridization state, the Si is sp3 hybridization. Then silicon in hybridization state, silicon gain 4 electrons, that is s and the p orbitals which contains each 1 electron. Silicon tetrachloride, in which s orbital there is again 1 electron, p orbital there is a px, py, pz orbital, again the 3 electrons, means 4 electrons that can be gained from the chlorine atoms. 4 sp3 hybrid orbitals which get formed, and there is a tetrahedral structure. Bond angle of this silicon chlorine is 109 degree 28 minutes. Tetrahedral structure of silicon tetrachloride is formed. Structure of silicon tetrachloride is tetrahedral involving sp3 hybridization. 4 hybridized orbitals of silicon overlaps with a half filled 3p1 electron of 4 chlorine atoms. Thus, the geometry of silicon tetrachloride is a tetrahedral with a bond angle of 109.5 degree. Then the silicon is prepared by the reduction of silicon tetrachloride. A stream of silicon tetrachloride vapors is passed over heated metallic sodium SiCl4 plus 4Na. It gives 4NaCl plus Si. The excess of alkali metal and alkali salt formed are removed by washing with dilute acid and finally by water. Silicon tetrachloride is used as a raw material or intermediate in the production of silicon, Si, silica, SiO2 and other silicon based substances, silicones, that is organosilicon polymer. Silicon tetrachloride is a starting material for the production of pure silicon for manufacture of semiconductors and optical fibers. The silicon tetrachloride reacts violently with the water to give white solid silicon dioxide and streamy fumes of HCl. The hydrolysis of silicon tetrachloride gives salicylic acid when upon heating undergoes a partial dehydration to give silica gel. SiCl4 plus twice S2O. It gives SiOH4 salicylic acid. Then further it gives SiO2 plus 4HCl, SiO2X-S2O. Silicon tetrachloride plus alcohol, ROH. It gives the SiOR4 plus 4HCl, tetraethyl orthosilicate is formed from the ethylene and silicon tetrachloride. At higher temperature, homologous of silicon tetrachloride can be prepared by the reaction Si plus twice Cl, SiCl4, Si plus twice SiCl4, it gives Si3Cl8, gives a polysilicon chloride. In fact, the chlorination of silicon is accompanied by the formation of hexachlorodisilane, Si2Cl6. 4 are lithium, organolithium compounds plus silicon tetrachloride. It gives R4 Si, organosilicon compound plus 4 LiCl, lithium chloride. The reduction, that is silicon tetrachloride plus twice S2 gives Si plus 4 HCl at 1250 degrees centigrade. Silicon tetrachloride plus Si gives Si2Cl6 plus higher members of the series. The hexachlorodisilane, that is Si2Cl6, it is prepared from silicon tetrachloride plus Si. Thank you.